Hello everyone. Let us see the next example of ordinary differential equation. In last lecture, we have studied exact and non-exact ordinary differential equations, and we have studied how to convert non-exact equation into exact differential equation by finding the proper integrating factor depend on the type of the equation and multiplying with that proper integral factor to the whole equation. That equation reduced to exact differential equation, and once it reduced to exact differential equation, we know the solution of that equation. Okay, and let us see the next example. Y dx minus x dy plus log x dx is equal to 0. In such type of example where there are two terms of dx, we have to first step, our first step will be combine this dx first. Okay, therefore y plus log x into dx, this is the m, the coefficient of x dx, and this is minus x dy is equal to 0. This is in our format, there's a dm dx plus n dy. Okay, so whenever the dx or dy terms comes in the multiple times, you have to combine those terms, okay, to make the only single term. Now comparing m dx plus n dy, this is your m, this is your n, including this minus sign. M is y plus log x, n is minus x. Now we have to first check whether the equation is exact or non-exact. For that, find out the m derivative with respect to y, that is dou by m by dou by y. In that such, this is a partial derivative, that's why with respect to y, x is constant. Therefore y derivative is 1, x is constant, that's why log x is constant, and constant derivative is 0, that's why derivative of m with respect to y is only 1. Now derivative of n with respect to x, we have to find out, that is minus 1. Both are different, that's why it is not equal. That's why the given differential equation is non-exact equation. Now to find out the proper integral factor, whether we have to find out whether this equation fit in any one of the four given forms of a integral factor. First, is it a homogeneous? No, it is not homogeneous, because there are three terms, okay, and out of three terms it contains log x, okay, and we cannot find out the degree of this log x. Whenever log x, sin x, e raised to x square exponential function is there, we cannot count the degree. That's why that is the only thing we cannot conclude, that is it is not a homogeneous, first condition. Now second, is it of the type y dx and x dy? There is only x into dy term, but there is no any y into dx term. It contains y log x, okay, that's why it is not of the second type also. Okay, now out of third and fourth type, we have to find out whether which type we have to calculate some terms. Now which term we have to calculate first, it depends on the m and n expressions. Now it is a shortcut, which expression is shorter, n expression is shorter, that's why that we have to check that condition first, where n is in the denominator, that is this term. Okay, now first dou by m by dou by y minus dou by n by dou by x divided by n, and whatever the answer of this term should be in x only, it doesn't contain y. That's why let us see, dou by m by dou by y is 1 minus dou by n by dou by x minus 1 upon n is minus x. 1 minus minus of 1 is 1 plus 1, that is minus division as x as it is minus 2 by x, which is wholly function of x. We call it as f of x. That's why it is this type of such type of integrating factor is equal to e raised to this fx into dx. Put this value of fx here, we get minus 2 constant outside of the integration, 1 by x dx. Now 1 by x integration is log. Generally, and most of the example contain only log integration. E raised to minus 2 as it is, 1 by x integration is log x. Take this minus 2 on the index of this x by using log property. It becomes e raised to log x raised to minus 2. Now e and log gets cancelled. Answer is only this x raised to minus 2. And put in the denominator to make the positive indices. It becomes 1 upon x square. This is the integrating factor. Now next step will be multiply this given equation by this integrating factor. Therefore multiply equation, call that equation number 1, this one, by our integrating factor 1 upon x square. Both side it will become the exact equation. It becomes y plus log x 1 upon x square dx minus x upon x square dy is equal to 0, and which is our exact equation. And how to solve exact equation? We know the formula. This one is the formula. Now simplify, separate out this terms. Y upon x square plus log x upon x square dx minus 1x gets cancelled, 1 upon x dy is equal to 0. Now these are our m and n, new m and n. Now therefore the solution is, this is the exact equation, therefore solution is integration m dx, this is the formula, plus integration n dy, terms free from x, m y constant, is equal to integration constant c. Now what is m? M of this equation, not the earlier one. Okay, m is this total term, keep it as it is, dx, and plus this is our n including the minus sign, and n is not free from x. Here m is easy, but n doesn't contain terms free from x. There is only one term which contains x. That's why n value is 0, is equal to c. Now 0 integration 0. Now here y constant, therefore take a y outside, and 1 upon x square integration. How to solve it? Take x square in numerator, it becomes x raised to minus 2. Integration is apply x raised to n integration, x raised to minus 2 plus 1, that is minus 1 upon same number minus 1 plus. Now keep this integration as it is because we have to solve it separately, is equal to 0 integration 0 is equal to c. Call that equation number 2. Now consider this integration. Let I is equal to this integration log x upon x square dx. Now we have to solve this integration by u into v rule, where u is u and v can be decided by this Lie function. This is logarithmic, that is why it is u, and rest of obviously v, arithmetic. Now I becomes, now integration u into v is, see, in this example we have to use the regular u into v rule. U into integration of v minus integration of this integration of v into derivative of u. Okay, this integration we have to use dx but of this. Now consider, because in u into v general rule u derivative should be 0 somewhere, but here u is log x, and log x derivative is cannot be 0 at any point, because see, u into v rule is u into v1 minus u dash v2 plus u double dash v3 minus, and so on. This is an infinite series where this formula is applicable when this derivative somewhere becomes 0, then and then only this becomes the finite series. Okay, because derivative of any function can be comes to 0. We can find the function whose derivative is 0, but integration of any function we cannot find such function whose integration is 0 in standard formula. For example, suppose x cube in derivative, take on derivative of x cube, what it becomes? First derivative 3x square, second derivative 6x, third derivative 6, and last fourth derivative is 0. Okay, if you take integration of x cube, first integration is x raised to 4 by 4, second integration is again x raised to 5 upon this 5 into 4 is 20, third integration is again x raised to 6 upon 120. It never comes to 0. Okay, that's why this series, it depend on the u factor, where derivative of u should be equal to 0, but in our case u is log x. Log x first derivative is 1 by x. 1 by x derivative is minus 1 by x square. If you take on derivative on or derivative of all such functions, log x derivative never be equal to 0. That's why we are not using this formula for our this integration. We are using the other formula. Okay. Now put the value of u here, log x into integration of v is log 1 upon x square integration. How to calculate? Integration of x raised to minus 2. Integration is x raised to minus 2 plus 1 minus 1 upon minus 1. Okay. Minus integration of this integration as it is here into derivative of log x is 1 by x dx. Okay. Now it becomes minus, take x to the denominator to make it positive, and thus log x upon x. This minus minus becomes plus 1. This x comes to denominator, it becomes x into x, that is x square. And again 1 upon x square integration is x raised to minus 1 upon minus 1. It gets solved. Again minus minus, take in the middle sign, x comes to the denominator, and combine this x as denominator is same. Answer is this. Okay, now put this value in above answer. We get solution is from 2 y into minus y upon this x comes to denominator x minus this integration is this integration minus as it is this 1 plus log x upon x is equal to integration constant c. Okay, this is the solution. Let us see next. Y log x dx plus x minus log y dy is equal to 0. This is homework for you. This is m, this is n. Answer is x log y minus half log y bracket square is equal to c. In this example, this is the hint. In the middle of the example, you have to solve this integration of log y upon y, and it can be solved by using again substitution. Put log y is equal to t, take derivative on both sides, 1 upon y into dy is equal to dt. Put this value here, it will becomes log y is t, 1 upon y dy becomes dt, and t integration is t square by 2. Again put t value, again resubstitute log y. Answer is log y square upon 2. This is the integration of it comes in the answer also. Okay, now this is the homework for you. Now let us see next homework again. dy by dx is equal to x cube plus y cube upon xy square. If such type of example is given, then you have to make this in our format, that is m dx plus n dy. That's why cross multiply or take this term on that side, this dx on that side, it becomes x cube plus y cube into dx is equal to xy square into dy. Now take this dy on that side, we get this form, this example, call that equation number 1. This is in the form of m dx plus n dy, where m is this and n is minus xy square. Solve this example, you will get the answer log x minus y cube upon 3x cube is equal to c, and integrating factor of this example is 1 upon x raised to 4. Now let us see next example. Solve y raised to 4 plus 2y dx plus xy cube plus 2y raised to 4 minus 4x dy is equal to 0. Again this is homework for you. This is m, this is n. Answer is xy plus 2x upon y square is equal, plus y square is equal to c. Now hint for this example is integrating factor is equal to this one, and answer for this is minus 3 upon y. We have to call it as f of y by theory, and integrating factor is e raised to integration of f y dy. Answer is 1 upon y cube. So all the example further you will get this answer. Okay, now let us see next. Solve x square y square plus xy plus 1 into y dx plus x square y square minus xy plus 1 into x dy is equal to 0. Okay, m is this. Before that, take y inside to this bracket to define proper m. We get x square y cube plus xy square plus y into 1, that is y. And n is, take this x inside, we get x cube y square minus x square y plus x. Now take the derivative of m with respect to y, that is dou m by dou y. You will get the answer 3x square In such case x is constant, therefore x square keep this as it is, and y cube derivative is 3y square, plus again y square derivative is 2y into x as it is, and y derivative is 1. Now take n derivative with respect to x. We get 3x square y square minus 2xy plus 1. Both are different totally because middle term is one is plus, other is minus, therefore it is not an exact differential equation. Therefore del by n by del by y is not equal to del by n by del by x, which implies this is a non-exact equation. Now above equation is of the type of obvious f of x y y dx plus g of x y x dy, because y is attached to x and x is attached to y. This is a type 2 second type of integration factor. And what is integrating factor of such type? 1 upon mx minus ny. Put the value of m and n here. This is m, this is n, and this is x, this is into y. Simplify this by removing all the brackets. You will get this term, all the term gets cancelled, and it becomes x square y square plus x square y square is 2x square y square. Rest terms cancel. Okay, similar and opposite in sign. Now multiply above our equation by using this integrating factor of equation number 1. We get 1 upon this 2x square y square into this our original equation. Now take this 1 upon 2x square y square inside. You will get this function. Cancel out all the similar indices. You will get this m into this new m dx plus this is dn dy. This is an exact equation. After multiplying integrating factor, it becomes exact equation. And this is m, this is n. Now solution is, again this is the formula as usual. Now put this value of m, this is m as it is here, y constant, plus we have to find out this is n, terms of n which are free from x. This term and this term contain x, that's why the terms which are free from x is only this term including this minus sign, that is minus 1 upon 2y. dy is equal to c. Now take the integration as usual. Here y constant and here 1 upon y integration is log y. These are the steps. Simple integration is there, and combine this log x minus log y is log a by b formula, log a minus log b. We are using this simple formula here. Answer is this. Okay. By multiplying both the side by 2, because 2 gets cancelled and 2 comes to c, 2 into c, that is 2 into constant is again a constant. You can keep this c as it is. Constant into constant is constant. You don't need to write the different notation for that. This is the homework for you. So y square plus 2x square y dx plus 2x cube minus xy dy is equal to 0. This is m, this is n. Answer is this. Now this is second homework. 4xy plus 3y square minus x into dx plus x into x plus 2y. Before writing n, take this x inside to this bracket into dy is equal to 0. Now answer is this. Okay. Now application of these are the types of differential equations. We have studied linear equation, then reducible linear equation which are called Bernoulli equation, and then exact differential equation, and now non-exact differential equation, where we find particular integrating factor, then multiplying by those integrating factor to our given equation, we reduce non-exact equation into exact equation. Now after that, the last point of this chapter is applications. Whatever we are studying the differential equation, we have to study the application where these differential equations can be applied. Okay, application of differential equation. Now first application is to find out the orthogonal trajectories. Orthogonal trajectories mean the trajectories means curve. The curves orthogonal means the figures, geometrical figures which cuts each other or intersect each other in 90 degree. Okay, these are called orthogonal figures. Trajectories mean curve, the curves which cut each other in 90 degree. For example, how to find out that, or what is the meaning of that? So this is xy plane, this is first curve, okay, and suppose this is second curve, okay. This curve and this curve intersecting at this point, okay. Take the tangent to this curve. Tangent we know, okay, the line which touches the curve in one point, okay, and take the tangent to this curve at the same point, okay. And if the angle between these two tangents is 90 degree, then two curves are called orthogonal curve or orthogonal trajectories. Okay, this is the basic concept of orthogonal figures. Now let us see how to find out orthogonal curve of one given curve. Means what? In the example we have given we have given one equation of one curve. We have to find out equation of other curve. That is the orthogonal trajectory equation. There are two types. First we have to find out orthogonal trajectories in Cartesian form, and then we have to find out orthogonal trajectories in polar form. Cartesian means where x and y are there in the equation, x and y coordinates are there, okay, and polar means where r and theta is there, distance and angle. Okay, let us see the steps first in Cartesian form. Step 1. There are total 4 steps in Cartesian as well as polar form. First step, and all the steps are similar to each other. First step is differentiate the given equation of the one curve in the example with respect to x to get dy by dx. How to do it we are going to see in the example only. Now second step will be eliminate the constant from the equation. In the equation, except x and y, there must be alphabet a, b, c, whatever it is. This constant we have to remove. Okay, how to remove we will see in the example. Third step, replace the dy by dx, this dy by dx in the equation by is equal to, directly we are going to write dy by dx is equal to minus reverse dx by dy. Okay, now in some example we are it is very convenient to exchange this two step. You can do second step first. You can do the constant elimination and then replace, or you can replace first and then you can eliminate the constant. Okay, according to the example, it is okay to exchange these steps. Now last step will be, once we replace and eliminate the constant, we have to solve the given equation by using earlier any method. Okay, let us see the example based on these steps. Example number 1 is find orthogonal trajectories of the, this is the given equation, y square is equal to 4ax. Okay, first step will be call this equation, write down the given equation as it is and call this equation number 1. Now first step is differentiate given equation to get with respect to x, to get dy by dx. Now differentiate above equation with respect to x. Y square derivative is 2y and y derivative should be multiply, because we are differentiate given equation with respect to x, not y. That's why y derivative should be multiply using chain rule, that is dy by dx is equal to 4ax derivative is 4a with respect to x. Okay. Now second step will be eliminating constant or replacing step. Now what is the constant in this equation? A is a constant. And what is our step? Eliminate the constant, means you have to eliminate this a from here. Okay, So common method is whatever the equation you will get from differentiating, from that uh, put the value of that constant in the given equation. Now from this given equation, either you can get a by cancelling 2 from both side, or take this 4 on that side, or you can cancel out 4a also, doesn't matter. Now 4a, we are directly getting 4a, that's why I put this value of 4a in this equation. This step or this calculation is depend on equation to equation. In each example this step is different. How to remove the elimination, how to eliminate the constant, it depends on us, our comfortness, or the given equation. Now put this value here, we get this equation becomes y square is equal to this 4a, means this 2y dy by dx, into this x as it is. Now if you see this equation, there is nowhere a is there. That means second step is complete here. Third step, second step, eliminating the constant. Okay. Now third step is replacing the dy by dx by reverse minus dx by dy here. Okay. Now replacing dy by dx is equal to minus dx by dy. The equation becomes y square is equal to 2xy, and dy by dx becomes minus dx by dy. Now last step will be, this is the third step complete. This is very easy step, and last step will be you have to solve this given equation. Okay. Now whatever the resultant equation, we have to solve. Our equation is this. Now we have to solve by earlier method. Take this minus in middle, we get minus 2xy dx upon dy. Take dy on that side. Most of the example are of exact non-exact form. We get y square dy is equal to minus 2xy dx. Now take this minus 2xy on that side, we get y square dy plus 2xy dx is equal to 0. Now cancel out 1y, because on RHS side 0 is there. Divide by y, because 1y can be cancelled. It becomes y dy plus 2x dx is equal to 0. Okay. Now it is one form. You can solve this equation by m dx plus n dy, or directly you can integrate this equation. Why? Because whatever y terms are there which are attached to dy, dy term doesn't contain x, and dx term doesn't contain y. It is the one form which is called variable separable form, where x terms are attached to dx and y terms are totally attached to dy. In such case, we are directly differentiate this equation, integrate this equation to cancel out the dx and dy. Okay. That's why next step is integrating above equation. We get integration of y dy plus integration of 2x dx. Y integration is y square by 2 plus 2 as it is, x integration is x square by 2. 2 gets cancelled, we get y square multiply by 2, or you can y square by 2 plus x square is equal to c. Now multiply by 2 to make it simple, it becomes y square is equal to y square plus 2x square divided by 2. That 2 comes to this side, multiply by c. 2 into constant is constant again, they keep it as it is. Okay, this is the solution. These are very easy examples. Okay, second example is 2x square plus y square is equal to bx. Call this number 1. In this example, b is the constant. We have to eliminate this constant in second step. The first step is differentiate given equation. Differentiating with respect to x. 2x square derivative is, differentiate means taking derivative. X square derivative 2x, 2 to the 4x plus y square derivative is 2y divided by dx is equal to bx derivatives, x derivative is 1, b as it is constant. Now second step will be, we have to replace this eliminate this constant. To eliminate this constant, this is the value of b. Directly we are getting value of b. Put this value as it is here in the given equation. Therefore it becomes, put this value in equation number 1, we get 2x square plus y square is equal to b into x. This b, multiply this by into. Now put this value in equation number 1. We get 2x square plus y square is equal to b, this is b, into 2 into x as it is. Now multiply this x inside, we get 4x square plus 2x y divided by dx. This is our second step complete, eliminating the constant. Okay, this is our equation. Now third step is replacing dy by dx by minus dx by dy in the given equation. We get 2x square plus y square is equal to 4x square plus 2xy as it is, and dy by dx comes to minus dx by dy. This is our third step complete. Now we have to solve this equation. To solve this equation, make this equation in our regular m dx plus n dy form. Okay, for that take this 4x on this side, on this term on this side, and negative term on that side. We get 2xy or 2yx dx by dy is equal to 4x square. This term comes to this side, it becomes minus 2x square minus y square. Now take dy on that side, we get 2xy dx is equal to this term, put this bracket into dy. Now again take the whole term into this side, we get 2xy dx minus this term into dy is equal to 0. This is our m dx plus n dy. This is m and this is with minus sign, this is n. Now solve this equation by any method. The answer is this. Okay, try to solve. If you have any problem, just we will discuss on next lecture. Okay.